Hi everyone. I will explain about Euler or Euler formula. How can an exponential function equal a sinusoidal function? So first, let's talk about Taylor series. So by using Taylor series, we can represent a function by taking the derivative of its infinite sum. This is the general formula of Taylor series. F to the n order at a is the position and f is a function of a, and factorial. If you wonder what does factorial mean, it is the product of itself with a lesser value of it. So for example, factorial of 5 is 5 times lesser value of it is 4 factorial. It's also equal 5 times 4 times 3 factorial, and this will equal 5 times 4 times 3 times 2 times 1, and there is a rule that 0 factorial is equal 1. Okay, so let's try an example. First example, let's represent psi of x, function psi of x at a equals 0 by using Taylor series. Okay, so at n equals 0, the zero order derivative is itself a0, and 0 is 1, x minus 0 is x to the 0 power, which is 1, so we should have psi of x or psi of 0. This is the first order, the second order, the third order. Okay, so the first order is 0, the second order is the first order plus the second order is x, the third order is sum of the previous values. So 0 plus x plus 0 is x, and the fourth order is itself plus of the previous value, so will equal x minus 1 to the factorial of 3x cubed, and after calculating we'll get this series, and from this series we can generalize this equation or this formula for function psi of x. Now let's look at the plot to see how Taylor series works. Okay, so at first order, psi of x is just 0, which is a horizontal line. Then the second order, we have x, which is the diagonal line, and then fourth order we have polynomials. So yes, it looks like a polynomial graph or plot, and then as the order increasing, we see it look more likely as a graph of psi of x. I believe this is minus pi, and this is pi, because yeah, so it's around 3.14 minus 3.14. the green line second is 20 orders, the orange line is 20 orders. 20 orders is pretty close. Okay, so now let's try to find or represent exponential function by using Taylor series. So also we apply a general equation that I mentioned above, that calls Formula 1. So when we apply Formula 1, we'll get this series, and from this series we can generalize this formula for exponential function. But if you need a little review, so we wonder what is E, what is it? Okay, so E is an irrational number. It had a value of 2.71828 and continue, and is defined as a limit from n to infinite of 1 plus 1 over n to the power of n. And E also called Euler or Euler number. That's why it's had a letter E. Okay, now let's look at D2 series, Taylor series. It has 10 order. Okay, 10 order of function psi of x and 10 order of functions cosine of x. And if we add these two functions together, we get this equation. And then we know that and when we look at this equation compared to the exponential the Taylor series of exponential function, we see is similar to each other except the sign of these values. So the coefficient of x to the power of 7 is, and x to the power of 6 is minus. Also x to the power of 3 and x to the power of 2 is minus. But all the coefficient of the exponential function is positive. So how can we change it? We know that natural number I equals square root of minus 1, and square root of I is minus 1, square root of 3 is that, okay, equal I times I to the 6, which is minus 1, so it will minus I to the power of a equal minus I, so it will be equal 1. Okay, so x to the power, this is minus I, 6 is minus 1. So if we add I right here, if we add I to the exponential function, let's see what happened. We'll get this side change, which is identical to the function of cosine of x plus sine of x. But as we notice, the coefficient of sine of x has I, so power of 7, power of 9, power of 5 has I, minus power of 3 also have I, so we can multiply I with sine of x, and now we can say that e to the power of ix equal cosine of x plus I sine of x, and this is Euler formula. Thanks for watching.